Okay, today we're going to talk about how to use the calculators to construct our confidence intervals. Assuming all the conditions that we discussed yesterday are met as far as simple random sample and a sample size, and remember we have sigmas known in this, we can use the calculator to do this. You'll find this under the stat menu, and then you have to arrow over to tests and use Z interval. That's what we're working with. We'll do one in a minute. From there, you can either pick if you're working with raw data or statistics, fill in information, and press calculate. The calculator does not give you a margin of error, it just gives you the interval, but it's really easy to find the margin of error if you just take your mean and subtract one of your endpoints. The same rounding rules apply as before. So let's take a look at one. The owners of a local company that produces hand-knitted socks want to know, for women in the area, the average length of a woman's foot from toe to heel. They collect data from 431 randomly selected women. Okay, so our N is large enough and we're a simple random sample, so we're good here. The sample mean is found to be 8.72 inches. We want a 95% confidence interval for the mean length of a woman's foot in the company's area using the calculator. And we also want to find the margin of error. So we're assuming that we know the population standard deviation is 0.36 inches. Like we talked about yesterday, you don't ever know the population standard deviation. We'll deal with that problem tomorrow. So what we're going to do is go to the calculator. We're going to go straight to the stat menu. You have to arrow over to tests and then down to Z interval. That's the one we want. If you have data, raw data, you would need to input it into L1 or L2. Which we don't have that, we have statistics. So you're going to arrow over to stats and hit enter, and then it gives you this. So we know that our standard deviation is 0.36. We know that X bar, that's our mean from our survey, from our sample mean, 8.72. N is the number of people, that was 431. And then our confidence level, we can just put it in here. We have a 95%, and then we're going to click on calculate. And here it is. Right here, they give us the interval for that. So we'll write that down over here. So our interval is 8. So our rounding rule is we get same as the standard deviation. So 8.69 to 8.75. Okay, and again, you don't automatically do just what your calculator does as far as rounding. Make sure you're using the rules we were talking about yesterday. We want to do the same number of decimal places as your standard deviation. So to interpret this, we would say something like, we are 95% confident that the true mean length of a woman's foot in this area is between 8.69 inches and 8.75 inches. Okay, so this is the net that we have cast that has hopefully caught our true mean. Okay, so I'm going to write that down. We are 95% confident that the true mean length of women's feet in this area is between 8.69 and 8.75 inches. Okay. Now, a note about this is written right below. We can not assume that the true mean is anywhere in this. We don't know that it's directly in the middle. It could be just as likely to fall directly in the middle as it is to fall at either endpoint. Okay. One other thing is they wanted us to find the margin of error. Again, I told you that the TI doesn't actually give you the margin of error, but all you have to do is take one of these, either endpoint, and subtract your mean, which was 8.72. So 8.75 minus 8.72 is 0.03. that's our margin of error. You could have done it with the other one, 8.69 minus 8.72. You get the same margin of error. So you can calculate it there. Make sure as you're doing your homework that you are interpreting, okay? All of those homework problems say interpret your results. That means write a sentence, okay? Your answers should not just be numbers. We have to explain what these mean. All right, our next one, we want to see example 8.7 in our book. And I took a picture of this because I don't have the book right here. Here it is, okay? So we have a study comparing the sensitivity of HIV home tests to that of professionally administered tests, same testing procedures. And then this confidence interval shows the correctly labeled positive when HIV is actually present. So if you take an HIV test and it says it's positive, you want that to be correct. So this is the confidence interval for that. So this is the sensitivity. So for a home testing method, the confidence interval for that sensitivity is between 86.6% and 96.9%. For the professionally administered one, like at a doctor's office or a hospital or something, it is from 95.85% to 99.08%. So we want to know which of these statements is the most unbiased interpretation. So which one of these is the best interpretation? So the professionally administered tests, this is I, the professionally administered tests were found to be far more reliable with 99.08 sensitivity than the home tests with only 86.6. Well, that is not a valid conclusion because for the professionally administered one, they're taking the highest endpoint, 99.06, and comparing it with the lowest endpoint down here, 86.6. And as I mentioned before, we don't know for sure where in this interval it might be. Okay? You can't say it's at one end or the other or directly in between. It's just somewhere in there. So I is not going to work. So let's look at number 2. Home testing methods for HIV are just as sensitive for those as those administered professionally. In fact, they are even more sensitive since they have a possible of 96.9% sensitivity, I think that's a typo in your book, rating compared with a possible 95.85% rating for the professional ones. Well, again, they are looking at 96.9, which is the high end of this, and then for the professional ones, they were looking at 95.85%, which is a low end. And again, you can't pick and choose. So this is not a valid conclusion. Now, you have to flip over to the next page to see choice 3. Here it comes. The results provide reasonable assurance that the home test is as effective as the professionally administered test. This is true. The third one is true. And let's go back to that other one so we can see why. Notice that these two confidence intervals, 86.6 to 96.9, 95.85 to 99.08, they overlap. Since they overlap, we can reasonably assume that they might have the exact same sensitivity if the home test falls on the high end and the professional one falls on the low end. So since there's overlap, we want to pick choice 3. Reasonable assurance that the home test is just as effective as the professionally administered one. So again, just wanted to reemphasize, you can't pick and choose inside that interval. The true mean could lie anywhere in there. We're going to do a couple more examples in the next video.